Hello, everyone, and welcome to the GeekNarrator podcast. I'm your host, Kaival Yapte, and I'm back with another very interesting topic to discuss. Today, I have Gunnar with me, who is a former project lead for Debezium, and he's currently working at Decodable. And he's deep into open source projects, open source contribution, a lot of experience with Java, and currently working with stream processing and everything around it. So I'm really excited because we are going to talk about change data capture and how Debezium solves that problem and how Debezium works and all the internals. And there's no one better than Gunnar to talk about it. So, Gunnar,
Awesome.
welcome to the show. And let's start with a brief introduction about yourself.
Sure. Thank you, KV, so much for having me. It's a pleasure to be here, and thanks for the nice words. So about myself, as you mentioned, I work as a software engineer. So far, mostly in this, let's say, over the last 10 years in the open source space. I've been working at Red Hat, and until this month, really, I just changed jobs. I just joined Decodable a few weeks back.
Yeah.
I've been working on Debezium at Red Hat for the last 5 years or so, and before that, I've been working on some projects from the Hibernate umbrella. So maybe folks have heard about bean validation, which is a spec for validating your Java objects. So I've been the spec lead for bean validation 2.0. And I've been doing some other open source projects on the side. So maybe you've heard about Mapstruct, which is an object mapping code generator. So I've been the original creator of that. I've done KCCuttle, which is a command line client for Kafka Connect. So I like doing open source and everything which comes with that. And nowadays, as I mentioned, I just joined Decodable, and this is a managed stream processing platform, which is based on Apache Flink. So I hope I also get to contribute to Apache Flink in the future.
Awesome. How did you get involved into Debezium? Can you share that experience?
Oh yeah, absolutely. I mean, it was, to be totally honest, it was kind of random because I was working, as I mentioned, as part of the Hibernate team, and so I had done Beam validation, I had done the reference implementation for Beam validation, and we had some other projects there. There was an experimentation which we did back then, which was about trying to see whether you could use JPA, the Java Persistence API, and marry it
Yeah.
with NoSQL stores. This was
Hmm.
called Hibernate OGM, Object Grid Mapper, and we tried to see whether we could use JPA to go to MongoDB and Cassandra and all those kinds of stores.
Yeah.
And I was involved with that, and I was just ready for a change, and I wanted to explore something new, having worked on Hibernate and related projects for the last 5 years back then. And then the original founder of Debezium, Randall Hauk, hi Randall, if you see this, he left Red Hat to explore a new opportunity. And well, there was this slot vacant for the project lead of Debezium, and I was looking for something new. And things came together. They asked me, "Hey, would this be something you're interested in?" And then I said, "Sure, let me give it a try." I haven't really done anything with CDC before. I didn't really know much about it, but the project looked cool. It was a community which was up and coming, and I thought, "Oh, sure, let me give it a try." And then things happened.
Yeah. Very cool. Very cool. Um, let's dive deep into the topic of today, which is change data capture. And I
Sure.
want to start really basic because maybe some of the viewers are not familiar with the terms, with the concepts, and they want to know more about it. So
Absolutely.
let's start by defining what do we mean by change data capture. I mean, I understand it's typically very straightforward, like the three words change data capture. So there's
Yeah.
some change in the data and you want to capture that, but
All right.
let's describe a little bit more on what it means.
Absolutely. Yeah, let's do that. Right. So as you say, it is about extracting changes from a database and allowing you as a user to react to those changes. So
Hmm.
let's say a new purchase order comes into your database and you would like to
Hmm.
be notified about this event and you would like to react to that event. Maybe
Yeah.
just to take that data and put it into another data store or data warehouse. And we can talk about use cases, but there's all kinds of applications for this ability to react to data changes with low latency. So that
Hmm.
is what it is about. And the way it works is essentially what you need to know about all the databases is, all the databases, they work with what's called a transaction log. So the
Mm.
transaction log, that's the source of truth in a database. And now if a writing transaction comes into the system, like an insert or an update or a delete, this will manifest itself as event in this transaction log. So that's an append-only data structure, essentially. And
Hmm.
from there, the table files are materialized. So now if you do a
Okay.
query in your database, you won't go to this log directly, but you will go to your table files, of course. But the transaction log, that's the source of truth. And usually it is there for two reasons in the database. The
Yeah.
first reason is to give you transaction recovery capabilities. So, I
Yeah.
don't know, your database server crashes, it comes back up online, it goes to this write-ahead log, and it will be able to, come back to a consistent state, maybe clean up some halfway applied transactions or completed this kind of stuff. So transaction recovery in case of failures, that's the one scenario. And the other use case for why databases have those logs is replication. So typically you would like to have something like a standby server, or maybe even like a fully distributed database, and essentially streaming the log files or their contents to other nodes in such a database cluster. This gives you high availability, resilience, and so on.
Hmm.
So that's why databases have those transaction logs. And now tapping into those transaction logs and essentially reacting if there are new events, this is what allows us to implement all those kinds of use cases and take those changes and propagate them to other consumers.
Yeah. That makes sense, and thanks for describing. It was very straightforward, and also giving a little bit of background, like why databases have these transaction
Right.
logs. It makes a lot of sense. What kind of updates are we talking about? Because there can be like very major updates to a row, or there can be like very small updates, like I don't know, just one column update, which is very, typical, and it's only updating, let's say, the updated at column or something like that.
Right.
So what kind of updates are we talking about here?
Okay. So, yeah, I mean, it depends, right? So the thing is, if you just need to update a few columns of of a table row, then it could be that only this particular information is actually persisted in the transaction log. And
Hmm.
now, if we go and look at the transaction log and this particular event, we wouldn't be able to see the entire record. Maybe, I mean, we always will see the primary key because that's like an essential information to identify
Yeah.
that record. But then we might just see those changed fields. And now,
Mm.
depending on your use case, this may or may not be enough. So maybe you would like to use those events to propagate data changes across microservice boundaries. In
Mm.
that case, I would say you probably want to expose a full state of a row. You don't want to give them just the changed fields. Maybe for another
Okay.
use case, you're fine with just showing those changed fields. And what
Yeah.
I'm trying to say is it can usually be a configuration in your database, whether it will give you the entire row and
Hmm.
maybe also the previous state in case of an update, or whether it gives you just the modified and updated fields, maybe just their new values. So that's a function of how your database is configured. Also, frankly speaking, how much space you want your transaction log to take up, because if you, of course, put in all this row state there and maybe also the previous row image, it
Yeah.
will just take up more space, right? So that's
Yeah.
the consideration you need to make.
Yeah. Okay. Okay. That makes sense. With this, let's start understanding what Debezium is and how it is solving this problem of change data capture. So,
Right.
yeah, what is it and how is it doing it?
Right. So, I mean, on a high level, you could essentially imagine it's a bit like another replication client, because in the end,
Hmm.
that's what we want to do, right? We want to react
Yeah.
to this stream of changes. And now the problem is, or the challenge is, there is not a single way how you could implement this for all kinds of databases. So, I mean,
Mm.
unlike JDBC, let's say, which is one generic interface and you can use it to talk to all relational databases, really.
Yeah.
There's no such a standardized interface for CDC. So this means we, as the Debezium team, or well, I guess I'm still part of the Debezium community, see, but let's say the
Yeah.
Debezium engineers, they need to do this effort to understand how do we implement change data capture for Postgres. How do
Hmm.
the APIs in Postgres look like to get changes out of it? How's the format there? Then how do we do this for MySQL? How do we do it for SQL Server, and so on? So it's a
Okay.
proprietary, different, specific interfaces, and this is the engineering effort which the Debezium team needs to make. But then they try to abstract that also for you as a user. So now, if you consume this change event stream coming from Debezium, this will be rather generic and rather abstract, which means you don't really need to care about the particular database this is coming from. So it doesn't really matter, does it come from Postgres, does it come from Oracle? It will look the same for you as a Debezium user.
Yeah.
And the big advantage to that is that, I mean, of course, we always try to align on, let's say, a small set of different technology choices, right? So ideally, we just have one relational database in our company. But reality is, it's not like that. I mean, you do acquisitions, you do different teams, and you end up always with this zoo of different technologies. So everybody has Postgres and Oracle and SQL Server, just to give an example. So they have multiple ones. And now, having this abstract and generic change event format for the consumers, this is very powerful, because if they want to implement use case, let's say take this data and put it into a data warehouse, let's say Snowflake, they don't need to care about the source database too much. And that's, I think, a huge advantage to that.
Mm-hmm. Yeah, that makes sense. And I'm just curious why there is no standard across databases.
That's a good question. I mean, maybe eventually there is. I mean, there's many aspects to that. So I would say traditionally CDC change data capture has been more of an afterthought for those database vendors. So they didn't really care about that to begin with, and this is why it's kind of this exploration for the Debezium community or anybody who wants to implement CDC to see how it's done for different databases. But actually, it also has changed a little bit. So nowadays, if you look at those modern cloud native data stores, mostly distributed like Yugabyte or Vitesse or CockroachDB, they actually have CDC capabilities pretty much from day one. So for them, it's not an afterthought. For them, it's really a native capability. And maybe that's an opportunity for establishing such a standard. And I also would argue that at least in the Kafka space, Debezium and its change event format, that kind of is like a de facto standard, actually. And we can talk a little bit, if you want to, about different connectors, who builds different connectors, because there's actually also people outside of the core Debezium community who do Debezium-based connectors.
Mm-hmm. Yeah, that makes sense. If I have to look at like a high-level, let's say, architecture diagram of Debezium, right? What components I'm looking at?
Right, that's a great question. And my short answer is there's different ways how you could look at it. But because there's different ways for using Debezium and deploying Debezium. Essentially, there's 3 different ways, and we can talk a little bit about those. So first of all, there is, let's say, what we would call the Debezium core, or the Debezium core connector framework. And this is essentially a Java-based implementation for extracting changes out of those different databases. So there's like a connector plugin for each database, which we want to support, but then there's like a common Debezium framework where they're all based on. So let's call it the Debezium engine. And now most of the times people use this via Kafka Connect, because traditionally the Kafka community, this was and still is by far the biggest adopter of Debezium, I would say. Now, for those people who are not super familiar with Kafka, there is there's of course Kafka, the streaming platform itself. But then, as part of Kafka, there's a few other projects under that umbrella, and one of them is Kafka Connect. And Kafka Connect is a development framework and also a runtime for those kinds of connectors. Either source connectors, which take data out of a data source, like a relational database, and put it into Kafka, or sink connectors, which take data out of Kafka and propagate it elsewhere to S3, Cloud, Snowflake, and so on. And most of the times, people use Debezium with Kafka Connect as source connectors in Kafka Connect. So that's, I would say, that is what 90% of the Debezium users do.
Okay.
Then we realized, there's lots of love in the community for Kafka. It's super popular, and it makes a lot of sense that we have first-class support for that with Kafka Connect. But not everybody is using Kafka. There is users on other platforms like Apache Pulsar, or maybe the managed ones on the cloud providers like Amazon or AWS Kinesis, Google Cloud PubSub. There's something on Azure Event Hubs. There is Pravega, there's Nuts. There's all kinds of event streaming platforms on-prem, in the cloud, and so on. And, well, ideally, all those users, they should be able to benefit from Debezium and be able to benefit from the capabilities of CDC. And this is why we came up with what's called Debezium server. And Debezium server, essentially in an architecture, if you would draw an architecture diagram, it would have the same role, the same functionality as Kafka Connect, but it gives you connectivity between Debezium and all those kinds of streaming platforms and processing platforms like Kinesis and so on. So that's Debezium server. And lastly, you can also use Debezium, the Debezium engine, embedded in your Java application. So as I mentioned, it's all Java and JVM based, and there's a way how you can just use it as a library within your own application. So let's say you build a Spring Boot application or you build a Quarkus application. You could use Debezium embedded there, and then you would just register a callback method, and this callback method will be invoked whenever there's a new change event coming in. And interestingly, this is used by a lot of integrators of Debezium. So let's say Apache Flink as a stream processing platform. There is native Flink CDC connectors which are based on Debezium. So they take this embedded engine, which allows them to, have changes ingested right into Flink without having to go through Kafka first, for instance. So those are the three ways: Kafka Connect, Debezium server, and Debezium embedded into your Java application.
Yeah, that makes sense. If we have to compare the approach, the third approach, which is the embedding approach, where you have a Debezium connector running inside your Java application, and you just like have a callback, and whenever something changes, it will make a call to, let's say, Debezium server. With this second approach, which is, Debezium is running, and then there is a server. So is it not embedded? If we talk about the second approach, and how do we compare both?
Right. Yeah, that's a good question. So essentially, you could say Debezium server is just a ready-made runtime process which takes the embedded engine and which runs this thing for you. And there's just a very thin layer of configurability around it and observability. So you have like metrics and stuff. And essentially, then you can configure Debezium server with, of course, the sources you would like to stream changes from, which Postgres database, which MySQL database, and so on. And then what we call the outbound adapter. So which streaming platform you would like to take those events to, like should it be Kinesis, where do you find it, and so on. So essentially, Debezium server is embedded engine plus a thin layer of configurability, observability around it, and it's given to you as a ready-made process, as a ready-made distribution, so you don't have to, provide this application boilerplate code by yourself.
Yeah, that makes sense. So as a Java developer, if I want to, so let's take an example, right? I have an e-commerce application. I always end up taking e-commerce as an example because it is so common.
I know. I do the same because everybody is familiar with the domain. People understand the examples. It makes lots of sense.
Yeah. So I'm placing an order. I have an order, right? And it goes to my DB because let's say I'm using Postgres, and then as a Java developer or an application developer, I don't have to worry about taking this data into somewhere else. I can just embed Debezium, and then it will take care of putting that data into somewhere else. Let's say Kafka or some other streaming platform. So I mean, it's mainly the ease of use and reducing the boilerplate that is Debezium giving it to me, right?
Well, it is that, but also there is a very important a notion of reliability to this, because this use case which you described, this is super common. Yeah. Let's say this purchase order comes in, you have a REST API for placing purchase orders. So yes, you want to store it in your database of the service. And then, as you said, you also want to send out a Kafka message to maybe to another service, to the shipment service or to the payment service, whatever. Yeah. And now the problem is those two activities, persisting your data in your database and sending a message via Kafka, those two things, they should happen atomically, right? You really want to be sure either both of them happen or none of them happens. And the thing is, you cannot ensure this if you do this basic approach by just doing those two things at once, because they don't share transactional boundaries. Yeah. So unlike XA transactions, which you could do with multiple databases, Kafka cannot just be part of such a distributed transaction. And unfortunately, I see this very often. So if I look at example code or blog posts, people do this all the time. They show, and I'm afraid it's also implemented in reality very often like that. So they persist this data in a database, and then they send this message to Kafka. And the problem is, it's not atomically. So what could happen now is they persist the data in their database, but then something goes wrong with sending out this Kafka message, which means now, or it could also happen the other way around. So maybe they, depending on how it's implemented, they send out this message to the shipment service, but then they haven't persisted the order in the database of the order service. So in any case, you end up with an inconsistency, which is very bad, right? Because first of all, you need to identify this, and then you need to reconcile it, and might be possible or not. So it's just something which you don't really want to do. You want to avoid those dual writes.
Yeah.
So that's always the biggest thing I tell people: don't do dual writes. And CDC change data capture lets you avoid that because, or it helps you to avoid it because you only write to your database, and then sending messages to Kafka or whatever. That's an asynchronous process which happens completely separate from that. And by the way, there's also another advantage to this kind of architecture, and this is in regards to availability. So let's say even there was a stream processing or a data streaming platform which could participate in XA transactions. Let's assume that there was such a thing. Maybe one sent out, I don't know, a JMS message or something. I would argue it's not good to do it because it reduces the availability of your application, because now you need to have multiple resources to be available for this particular purchase order request to go through. So your database must be available, and this data streaming platform must be available. You can connect to it, and so on. And of course, always something could go wrong. Maybe there's a network split or whatever. Now, if you only require your own database, I would say that gives you the best level of availability. And then, of course, well, if you cannot write to your own database, well, then things are in a very bad state anyways, right? So that's kind of a requirement, I would say. We need to be able to persist data in our database.
Yeah. That makes sense. With this, I want to ask you a question about changing the way we look at this problem, right? So typically what I do is, I get an API call, like create order, and I want to create it in my database as soon as possible. And then I also want to write it to a Kafka topic for which Debezium can help me, because it is doing it asynchronously, and you are just making one write, and the Kafka write is not in the critical path. So it's it's not impacting your availability. How do I reverse it? So let's say when I get an API call, can I reverse this? I just write it to a Kafka topic first, and then I have, like, let's say, multiple consumers. One for whatever analytics purpose, sending it to a notification service, shipping service, and then one that persists that data into the database. Have you seen this pattern as well?
Yes, I have seen it, and I have seen people talk about it. It is an option. I would just advise to be very careful about it, because it has some implications which you really need to fully understand to make sure you implement things in a reasonable way. The problem there is, or the main challenge there is, everything you do with Kafka is asynchronous. So if you do this produce requests, this will be asynchronous. So what this means is, if you go to Kafka, and by the way, I'm not meaning to pick on Kafka. Let me say, if you go to this data streaming platform, the next second, you would, you cannot really query it because it's a commit log, right? There is no way, there is no indexes, there is no key lookups or whatever. So you would have to subscribe to the log to actually ingest all the changes. So that's the first thing. You cannot even go there and say, hey, give me this particular purchase order. But let's say you were to stream from it, you were to consume from it, and you would get everything. It still is asynchronous. So you wouldn't just be sure that this data which you just inserted to a topic, that you already consume it. So this means there's some implications on what's called read your own rights semantics. So again, to stick with this purchase order example, the customer comes, they place their purchase order, and now the next second they want to go to their purchase orders view, and of course they would like to see this purchase order which they just placed, right? It would be
Yeah.
super confusing if it wouldn't show up, and then they would wonder, hey, did something go
Yeah.
wrong? Do I need to place it again? Did I, is it my mistake or whatever? So that's an experience which you don't want to give to the user. Of
Yeah.
course, there's ways to work around it. When you could, for instance, say, in that situation, instead of going to the log, I just memorize this newly produced purchase order in my application, and then I will show it from there to the user, and I don't have to go to Kafka. But then it gets tricky. For instance, let's say, how do you implement search then? So let's say the customer should be able to search in all the attributes. Now, how do you do this? Because there's some part of your state in memory, then there's the other state in Kafka. So how do you provide the consistent search? Maybe your application is scaled out. So now you need to think about distributing this in-memory state to all your application nodes, because you wouldn't be sure that the next request for the customer goes to the same application node. So another question is, how do you implement something like a unique constraint? Let's say you have a user subscription use case, and you want to make sure that only a single user can subscribe with a given email address. You don't want to have two accounts with the same email address. So implementing this just by going to Kafka, being all asynchronous, it's kind of impossible. You would have to serialize all the writes through a single writing process. I guess you can do it, but it's getting really tricky. So my long-winded way, that's my long-winded way of saying, yes, you can do it, but I really would advise in 99% of cases against doing it because of the implicit complications which this approach has.
Yeah. So basically, it depends on what guarantees you want to provide to the user and what kind of user experience is okay for you. So if it's okay to have a little bit of inconsistency, and if you are creating an entity but you're not able to see it, right after you have created it. If it's okay, then go for it. If it's not okay, then there are going to be some more complications. And adding this memoized value, or having it in memory and then showing it, it's just additional complexity that you don't need.
And my way of thinking about this, I guess I would want to have strong consistencies for wherever there's a user and there's they would expect a reaction to the things they just did. So somebody sits there, they want to see their changes to be reflected. So if I have this online database, this should probably have strong guarantees. Whereas then if I put this data into a data warehouse, and maybe there's like a view which gives me the aggregated revenue, like a dashboard of, purchase orders coming in the last hour or in the last day. But for somebody who looks at this dashboard, for them it doesn't matter, does it have the order from the last few seconds or not, right? They won't know about those orders anyway. So there it's perfectly fine to have this eventual consistency. And that's why I think exactly it makes sense to put Kafka between those systems, but not as the system of record for those online use cases where people interact with their own data.
That makes sense. What are the positives of this approach? So is there any positives? So we definitely talked about some use cases where, consistency is not a problem for you, so you can do it. I guess the availability part might be a little on the positive side, right? Like, because let's say Kafka is considered to be more available than, let's say, a SQL server or, MySQL. Is there any other?
I mean, I guess there is a point to be made about scaling, right? So let's say you have millions upon millions of concurrent requests coming in, and yes, you could ingest them to a Kafka cluster. Maybe you couldn't ingest all those changes to a relational database necessarily. I would say where I see more Kafka as the primary ingestion point, that's for things which are natural event streams. So that's something like a click stream or IoT data, this kind of stuff where you have like sensor measurements or whatever. Then it feels to me it makes lots of sense to go to Kafka first. If it's about those database-ish use cases, you probably want go through a database first.
That makes sense. I think that we also used similar approach in the IoT project because, it made sense. There was no user. It's just a lot of event stream coming up. Great. So coming back to Debezium, right? We said that, okay, if you write to a database and then you make a call to, let's say, Kafka produce, it might
Mhm.
fail, and then you have to have this retry mechanism. You have to do this atomically. What happens if something fails at the Debezium level? So let's say I'm reading the transaction log and I'm
Right.
producing to Kafka, but let's say Kafka is down or some other issue. Let's say the
Right.
process itself is dying or something. So what happens
Yes.
then?
Right. So that's a very important consideration in a Debezium project to think about those failure cases. So in all the documentations for different connectors, there's always a section, what if things go wrong? So we try to
Yeah.
reason a lot about it. So
Yeah.
most importantly, let's say the number one criteria is that we never miss any events. So that's really what we want to ensure. No events should ever be missed. So
Yeah.
if there's a bug where a user reports, so hey, there's this scenario, if I do this kind of changes concurrently, whatever, and then I'm missing events from the Debezium, that's always like the number one blocker bug criteria, and we want to fix them as soon as quickly. So that's what we really want to ensure. What can happen is that there is latency, or latency increases because, as you say, for instance, the Debezium process or Kafka Connect, it could not be running. So maybe you do a Kafka Connect version update, and then of course we won't stream changes from the transaction log. So their lag could be increasing. The general assumption is that if things go well, that there also won't be any duplicates. So let's say we want to do a version upgrade of Debezium or Kafka Connect. So what happens is you stop that connector and it will persist what's called the offset. And the offset, that's essentially the position in the log file from the source database, how far we got. And this again, the format, it depends on the database. But let's say it's just a number 1, 2, 3. So position in the log file. Usually, as it's more complex. There's like file names and whatever. But let's assume it's a single numeric attribute. And so this gets persisted. How it gets persisted depends on how you use Debezium. If you use Kafka Connect, this will be persisted in a specific topic within Kafka itself.
Yeah.
So we store this information. We got up to offset 1, 2, 3. And then you restart Connect and you restart Debezium, and it will read back this offset, and it will see, okay, I got up to 1, 2, 3 the last time, so now I need to resume this change stream from that particular offset. And then if all this goes well, we will just continue to read from there. We will then hopefully catch up with any lag. So if we haven't been running for half an hour, well, we would hopefully close this gap, and then we will be back in near real time.
Yeah.
Now, of course, things also could go wrong. So maybe you have like an out of memory error or whatever, and the process just crashes. Yeah. And then you could see actually duplicates, at least right now, because persisting this offset also is an asynchronous operation. So this means it doesn't happen after every record. It happens in intervals for the sake of efficiency. And now this could, what could happen is we persist. Okay, we got up to 1, 2, 3. Then we continue to read events from the log. Stream them, send them to Kafka, and then we crash. But we didn't get to updating this offset again.
Yeah.
Now you will restart Debezium, you will restart Connect, and we will again read from 1, 2, 3, and we will emit those change events coming after 1, 2, 3 another time. So this means consumers need to be idempotent, so they need to be prepared to see a change event which they saw before another time. And usually, I think that's not a problem, because you can, maybe it's just fine to see changes another time, and you just, because you will get back to the latest state anyways. So maybe you just can override everything, and it's fine. Or maybe you need to keep track of the message IDs which you have seen already, so you then are able to spot duplicates. So you are able to see, hey, I've seen this before. Yeah. And interestingly, and still sometimes people really want to have those strict exactly once semantics. So usually what you get right now with Debezium is what's called at least once. Yeah. So it is exactly once if things go well, but it could be at least once if things don't go well. And still, sometimes people want to have strong exactly once semantics. And now, luckily, Kafka Connect implemented support for source connectors for exactly once. I believe in the latest version, or maybe the version before, like 3.2 or 3.3.
Yeah.
And it's one of the issues for Debezium to take advantage of this exactly once support and then really provide those strong exactly once semantics. So I hope this will come in Debezium sometime soon.
Yeah, that makes a lot of sense. So the guarantees I'm talking about is at least once and not exactly once, because exactly once needs a lot more, tracking of
Right,
metadata and what kind of.
exactly.
So the in default mode, I think I'll get at least once guarantees, and I'm
Right.
expecting that the Kafka consumers are going to be idempotent. They need to keep track of if this is a duplicate event or
Yes.
whatnot.
Right.
When I'm producing, or when Debezium produces an event to Kafka,
Mhm.
does it provide it an ID to identify this
Yes.
event?
Exactly, it does that exactly right. So maybe on those change events, so what do they actually contain? So they contain, first of all, the state of the row, of course, right? So
Mhm.
if it's an insert event, or what we call a snapshot event, if you take an
Yeah.
initial backfill of the data into Kafka, it would just be the current state of that row. If it's an
Mhm.
update, you would have the before and the after state, before and after the change. Well, and if it's a delete, you would just have the delete, it's the before
Yeah.
state. So that's
Okay.
the actual structure, or the actual payload, let's say. And then there's
Yeah.
some metadata, like timestamps, when was this transaction committed, the transaction ID, of course, the table this event is coming from. Sometimes,
Yeah.
for instance, in case of MySQL, we can give you the query which caused this particular change. This can be interesting to see.
Yeah.
All kinds of other metadata, and then also uniquely identifying attributes which tell you specifically, okay, this is this particular event in the source transaction log. So there's like an LSN, a log sequence number, or something like that, and it allows you to unambiguously identify every event.
Mhm. That makes sense. Uh, in that sense, talking about the failure mode, right? So let's say the process is dying and
Mm-hmm.
it just emits the last stable offset, let's say 1 to 3, to a
Mm-hmm.
Kafka topic in case of Kafka Connect, and then it restarts, right? So
Mm-hmm.
it knows exactly where to read the next ones
Right.
from, but the ID that it is going to attach to that event might be regenerated, right? It can be a different sequence, or does
Uh,
it also track that?
so it would be the same, because those IDs, they are really coming from the source of from the
Okay.
database itself. So that's
Okay.
essentially it identifies this event in the source transaction log. So it's
Okay.
really, that's actually a part which is not generic, because this really, the format, like the number of attributes, the format of attributes, that is database specific.
Yeah.
But then, exactly as you say, so yes, technically it is a new event which we send to Kafka, but semantically it is the same. And
Same
if you
event. Yeah.
if you look at those events which uniquely identify it, then you will be able to see, okay, I see this event, and yes, it has a different Kafka offset, but
Yeah.
it has the same identifying attributes, so I know it's something I have seen before and I want to ignore it.
That makes sense. Yeah. Um, I want to talk about two more failure modes here.
Sure.
So one is so typically I have like
I like
a
it, like you how to go to all the tough stuff.
yeah. So I wanted to talk about, let's say I have a primary DB, all the rights go to that, and I have the replicas, and then let's say the primary dies, and
Right.
then you have, let's say, the Debezium engine running on the primary
Hmm.
as your process, and which is working fine, but then the primary dies, and then the
Hmm.
some of the replica needs to take over as primary. How
Exactly.
that failover and handover between the two Debezium engines work?
Right. Yes. So that's a tricky one. Definitely something to reason about as a user. The thing is, again, this depends a little bit on the particular database, because those failover modes and their semantics,
Ah,
they are specific to the database.
yeah.
So let's say, for instance, for MySQL, there is something which is called GT IDs, Global Transaction IDs, and
Hmm.
they allow us to do a seamless cut over to previous secondary, which is now the new primary server.
Okay.
And so, this will be like really seamless. Nothing gets missed, nothing gets duplicated. It just works fine. Of course, now the thing is, this new primary, it will have a different address, right? And now this could, for instance, mean you need to reconfigure your Debezium connector, so to point it to the address of this newly promoted primary server.
Yeah.
Or maybe you have something in between there, like a proxy, because people don't like reconfiguring their consumers or clients in case of a failover.
Yeah.
So there's proxies in between oftentimes, right? There is things like HA proxy or specific database-specific proxies, and they take care of this connection switch. And then for Debezium, it might mean just to restart because we lose the connection, or maybe we will just restart internally, and then it will be completely seamless. But then, for instance, for Postgres, it's a bit more involved because the thing to know for Postgres is there's this idea of replication slots, and replication slots, they essentially are like a handle, like a logical handle of one particular replication connection, like Debeziums, and also how far we have consumed this particular replication slot. So this is configured in Postgres. It's an artifact there, and now as of Postgres 15, as of the current version, there is no failover support for those replication slots. So if a Postgres standby server gets promoted to primary, you would have to create a new replication slot. Now, if you think about it, this can be a bit tricky because let's say you do the failover for your application, which writes to the database. If it already does writes before you have created this new replication slot, this means you would miss those events, right? Which isn't good. You never want to miss events. So you could work around it, for instance, by saying, okay, if I do a failover, by matters of procedure, I ensure that there is no writes to that database before I have set up the new replication slot. So maybe that's something you can do. That being said, and now that's interesting because you have worked at Zalando, right? And they did this Postgres operator called Patroni. And actually, they have implemented support for failover of replication slots. Now, I guess it gets a bit too much into the details of that, but they have found an operational way for how replication slots can be created on standby servers for Postgres and making safely use of them. So I would say if you are on Postgres, definitely, and this is a concern for you, definitely check out how Patroni does failover for replication slots.
Since it's reading the transaction log, and we expect that the orderness guarantees of how transaction log is written is maintained by the database. But is there a failure mode where things can go out of order, and how ordering is taken care of?
Well, I would say not really. I mean, the transaction log, generally speaking, is the source of truth in your database. So as the transactions are, applied in order, this is what's represented there. And going there, this will give us the right order of events. What could happen, for instance, is for some connectors and some modes of using them, we could actually expose your events from uncommitted transactions. So this could happen, I believe, for instance, in newer versions of Postgres. There is a way, if you want this, you can, let me take a step back. So let's say you do a very large transaction, which touches, 1 million of rows or 100 million of rows. If we only go to that transaction once it has committed, it could be, it means the lag increases. So sometimes, because this might take some time to apply this transaction, right? So sometimes people want to have events from a transaction before it actually commits. And now in the recent Postgres versions, I believe like 14 or something, they added support for logical replication, which is what we use, to get changes also from uncommitted transactions. So, then you will get the events from this large transaction as soon as it starts. But of course, you need to be ready to receive a rollback event. So maybe you receive those 100 million events, and then the user says, haha, actually, I roll back this transaction. So now this means, you probably don't want to emit those events, or you want to undo them, or whatever. So that's something to keep in mind. But otherwise, the ordering is strictly applied.
Interesting. whenever we work with these databases, we add new columns. We, let's say, I would say rarely remove something, but at least
Right.
change some types or any changes that I make
Yeah.
to a database, right? uh, how is this taken care, this migration that is happening?
Right. Yes.
Is there
Schema
like a
changes.
migration tool? Yeah, any schema changes, how is it
Yeah.
taken care?
Yes, there is no tool. It really comes back to you as a user to have process boundaries in place, I would say, to deal with this gracefully.
Yeah,
So let's say, I mean, we need to talk about different kinds of schema changes. So let's say
yeah,
you add a column. So this
yeah,
means there will be a new field in your data, in your change events. Usually
yeah.
that's just fine, because, well, a consumer should always be implemented in a way, I would argue, that it just is tolerant to seeing fields which it either doesn't expect or which are new to it. Maybe it just ignores those new fields, or maybe if you have like a JDBC sync connector, it would
Hmm.
recognize, so hey, there's a new field, so maybe I need to modify also the downstream schema and add a column there. So
Yeah.
that's usually fine. The other thing is, I mean, and then there's of course other kinds of changes, right? So let's say we change the name of a column. That's also not a huge issue,
Yeah.
because you can address it quite easily by putting some message transformation there. So if you use
Mm.
Kafka Connect, there is the ability to use SMTs, single message transformations, which are message by message transformations which run within Kafka Connect itself,
Yeah.
either applied to a source connector like Debezium or applied to a sync connector. And you can use this in this for this scenario, for instance, to add back the field using its old name. So it would be in the
Hmm.
messages twice, using the old name and using the
Yeah.
new name. And
Okay.
now this would give consumers some time to, adjust their logic to react to the new name. And then, of course, it's a matter of procedure. You need to talk to your clients and tell them, so, hey, if you do this kind of change and renaming for 1 month or for 6 months or for whatever, we will give you the old and the new name.
Yeah.
This is your migration period. And after
Yeah.
that, you only will get the new name. So,
Yeah.
that you can work around that. Or you
Yeah.
could also use Flink, for instance, for this kind of stuff.
Okay.
But then it gets more tricky again if you, for instance, change the type of a field, because this really is quite heavy, right? And I mean,
Yeah.
I would say it rarely happens, but it could happen. Maybe you expand the range of a numeric
Yeah.
type. Now, this means you need to adjust downstream schemas.
Yeah.
And then, well, how you go about that? I mean, maybe you just forbid those kinds of changes. I definitely am aware of projects who have monitoring in place where they track the schema changes, and if they see this kind of schema change which would break downstream consumers, they just don't allow for it. Or, well, you need to tell them, hey, we are about to expand the range of this numeric column. Please prepare your your downstream databases for that, so
Mm.
that you can receive those larger numeric values.
Yeah.
So really it comes back down. I would say it's a social problem, right? You need
Yeah.
to you need to bring the
Communicate.
different parties in your organization on the same page, talk to
Absolutely.
each other, and then I feel it's more a problem of that nature than it is a technical problem.
Absolutely. Database migrations are always hard, like schema changes and things
Right.
failing, and
Yes.
making anything backward incompatible is always an
Exactly
issue.
right.
You have to deal
Yes.
with hundreds of people who might be consuming that data.
Exactly right.
uh,
Can I
yeah,
add one more thought on that?
sure. Yeah.
Because one common concern I see people have or people ask when I talk about this is, and I think it's a very legitimate concern, is, so hey, aren't we exposing the internal schema of our database to the outside world? And is this not a bad thing to do? And so, yes, I think this is a very fair question to have, and we need to think about how we can answer it. Now, I would say, is it a problem or not? I would say it depends on your particular use case. So let's say you want to use change data capture to put your data into a cache or maybe a search index. Then I would say it's not a problem, because really in the cache or in the search index, we want to reflect the data as it is in our primary data store. So I feel, having this strict coupling of those schemas between our primary database and the cache, that's even desirable. So I don't think
Yeah.
it's a problem there.
Yeah.
But then there's other use cases where you maybe use change data capture to propagate changes between microservices between systems in a distributed systems landscape. So coming back to your e-commerce example, we want to place the purchase order, we want to persist it in our own database, and we want to notify the shipment service.
Yeah.
So there you could argue, and I would be very much on board with that, well, exposing our internal schemas and its changes to this external system and the team which maintains it, that's a problem. That's not something which is really desirable.
Makes sense.
There's then again different ways how you can go about it. So either you put in what you could call like an anti-corruption layer by means of transformations in between those things.
Yeah.
So to shield the downstream consumers from these changes. So that's an ability. And there's also another concept which I would recommend in that case, which is that's called the outbox pattern. And the outbox pattern, just briefly there, the idea is if you do your writing transactions, you update your actual business tables of your own domain model, and then you also insert an event into a separate table, the outbox table. And this is just like a message queue, essentially, which is meant for any external consumers. In that model, you would use Debezium just to capture the inserts, and it only would ever be inserts, to this outbox table. And you would stream those events, just those outbox events, to your consumers. And then the contract which you use for this outbox table, that's strongly decoupled from your internal model, and they could evolve in different with different velocities. Let's say you do this renaming in your internal model, you wouldn't have to do it in the message contract in this outbox table. So you would have a very strictly defined external messaging contract using this outbox pattern. So I would definitely recommend this one, depending on your use case.
Yeah. That makes sense. And actually, that was my next question. Like, you're exposing the database or the table schema to external systems. But I think as you said, it depends on your use case. And the outbox pattern sounds like a good pattern to follow when you don't want to expose that. With this, I have another question on the similar lines. So I've worked in different projects in different companies, but there's one common thing. There's this security team and finance team who don't want you to expose the PIIs to other systems, right? So let's say I have a PII in my database. There's, let's say, even phone numbers or email ID. Is there a way I can configure in Debezium that, mask these fields or something like that?
Yes, absolutely. There is. So yes, as you say, that's a very common requirement. So you could put in message transformations in place which are part of Debezium, so that's coming for you out of the box, where you could say either I just want to capture a few specific columns anyways. So maybe it's sensitive data you don't want to expose. Maybe it's just like, I don't know, people do it. They have like a large blob with an image in their table. I don't want to expose this one. So you could just capture a subset of your columns to begin with. Or you could mask them. You could say, I'm just masking the last 3 digits, all this kind of stuff, depending on what you need. So you can do it. And also, by the way, you could encrypt your data. And I need to make a plug for a project of a friend of mine, Hans-Peter Grase. So Hans-Peter, if you watch this, hey there. He has been doing a project which is called Kryptonite. And Kryptonite is a Kafka Connect message transformation, which lets you do encryption, field level encryption. So there you could say, I want to encrypt a particular field or a set of particular fields in my change events. And, then I exchange keys with my consumers. They can decrypt it. And, then you would have very securely, you would have a very secure way for transporting that data over the wire.
Yeah, that makes sense. With this, I want to slide away slightly from the traditional RDBMS systems and move to more let's say distributed systems or distributed databases, modern cloud native databases like let's say distributed SQL, Yugabyte or CockroachDB, or even some other non-RDBMS systems like, let's say, Cassandra or even something else. Is it also compatible with those databases?
Yes, I mean it depends on the database, and that you bring up Yugabyte, that's a very interesting point actually. So the thing is, there's different kinds, or let's say levels of connectors in Debezium. So there is those which tend to have been around for the longest time, like MySQL and Postgres, SQL Server, and so on. And so they are maintained by the Debezium core team. And if you go to GitHub, they would be under the Debezium organization on GitHub within the Debezium repo. So that's those, let's call them core connectors.
Yeah.
Then we have what's called the community-led connectors, which are also part of the Debezium organization on GitHub, and they're also part of Debezium releases. And that's the case right now for Cassandra and Vitesse. Vitesse being a sharding layer on top of MySQL coming out of YouTube originally. And those connectors, they are not maintained by the Debezium core team that much. They are maintained by folks from the community. So, for instance, in case of Vitesse, it's people from Stripe because they work with Vitesse. So they maintain this connector. And for Cassandra, this has changed a bit. It came from WePay, then people from Bolt came, from InstaCluster came. So, but people from the Debezium community who thankfully lead the work on those connectors. And they take part in the Debezium releases. So if you do a new Debezium release, they will be part of that as well. So that's the second kind, community-led connectors. And then and now it's getting actually interesting because we didn't quite expect this, or we didn't plan for this to happen. Folks elsewhere in the open source community took up the Debezium connector framework and built their own connectors based on that. And Yugabyte is one example there. So they have CDC capabilities in Yugabyte. They thought we would like to have a Kafka story, but instead of starting from scratch, we want to base this on Debezium because, well, we have the same event format as all the other Debezium connectors. We can reuse tons of infrastructure from Debezium in terms of how you go about creating messages, all this filtering stuff, which we discussed, Outbox support, snapshot support. So they all get this pretty much for free. And they decided to use the Debezium connector framework, but then host this connector, at least for the time being, under their own project, and they have their own release cycle and so on. So, that's like a third kind of connectors, I would say. And this is the case for Yugabyte and ScyllaDB right now. So like the Cassandra compatible NoSQL store. So they also have their own Debezium CDC based connector. And there will be another one for I cannot say it yet, but a very prominent and popular NoSQL distributed NoSQL store, which will also be based on Debezium, and I think it will be announced very soon. So definitely, this is a very exciting movement for me to see that those vendors also pick up the Debezium change event format, the Debezium connector framework to build their CDC connectors.
Yeah, that makes sense. How is it different when it comes to having it configured? So let's say I want to embed it, right? So is it different when it comes to these distributed databases, or it's the same way it is organized?
I would say it depends a little bit. I mean, yes, of course, the what you need to configure, this could differ a little bit, right? So let's say in case of MongoDB, as an example, you would maybe specify, for instance, a set of, Bootstrap servers is the Kafka terminology, but a set of MongoDB replicas servers you could connect to, right? So instead of just a single relational database node. So let's say those configuration attributes, they are specific, of course. And then if it comes to Cassandra, this one is actually a little bit different than all the other Debezium connectors because this one is right now at least not based on Kafka Connect. It's a separate own process, which you actually need to deploy on the Cassandra hosts themselves because it goes straight to a directory with log files. So this needs to run on the Cassandra machine itself or like on the nodes in the cluster.
Nice.
So the Cassandra one has a bit of a different deployment mode. We want to move this maybe to connect, but in any case to Debezium server. But that's a work in progress right now.
Okay, interesting. Let's talk about, so as a developer, let's say I have this e-commerce use case. Right. I also use Debezium to get my data into Kafka. But I want to, observe how this is happening, how it is performing. Let's say I have Black Friday coming up, so I want to prepare. What kind of metrics are available? So let's say I get this complaint like, okay, you know what? There's a lot of lag. So as soon as I get my data into my database, I see a lot of lag until it reaches Kafka.
Right.
How can I go forward and try to debug this?
Okay, yeah. I mean, again, great question. So, the standard way for how Debezium exposes metrics is via JMX.
Hmm.
It's just
Hmm.
very popular in the Java space, and there is
Yeah.
metrics which you get from Connect itself, and then there's tons of additional metrics which you get from the Debezium connectors on top of the Connect metrics. And yes,
Interesting.
there is literally a metric which tells you what's the lag behind the database, but
Mm.
then there's metrics for numbers of changes, like what's the last one which we propagated, um, of course memory and CPU usage. You would get that anyway. So there's really tons of metrics, I would say. So that would be a starting point. Then there's quite comprehensive logging. So if something isn't quite right, you could increase the log level and check out the logs of your connectors to see what it's doing. If you do a snapshot, so a snapshot is this initial backfill of data where we scan all the existing table data, but before we start to read the transaction log.
Yeah.
This can take quite a while. So then there's metrics which tell you, so, hey, this is the table we are scanning right now. This
Hmm.
is how far we got within this table. So you can get quite deep insight into those connectors and their metrics. And what I also observe is people then build dashboards from that, because
Mm.
so yes, it is JMX primarily, but then you can quite easily expose this as Prometheus compatible formats. And then people build data with, let's say, Grafana for
Mm.
operating their connectors, and then they would be alerted if lag increases too much, this kind of stuff, or if a connector is stuck, not running for whatever reason. So I'm always impressed or by how professional people are with operating those connectors, because some of them have like really large installations. There's users they use Debezium for with hundreds or thousands of tables. It's really impressive. They use
Yeah.
it at large scale, and of course they need to have this operational maturity, because if they have tons of connectors,
Yeah.
hundreds of connectors maybe, you cannot hand hold them, right? You need to be very efficient for configuring them, for monitoring them, and it's really cool to see what people do there.
Yeah. Yeah. Very interesting. And what kind of tuning abilities as a developer do I have? Is there like, can I make it faster by tuning something, or,
Yeah,
you know?
I mean, there is a notion of batching, which I guess is the primary option. So,
Yeah. Okay.
for how many records should we load into to process
Mm.
at once, and how
Yeah.
large should batches be built to be sent to Kafka. There's different polling intervals, which configure specific behavior. So there's quite a few options. Um, and yeah, sometimes I argue it's actually too many, because it's really you need to understand the different behaviors. Sometimes I feel it should be a bit more intelligent or ready to use. Maybe we should add
Hmm.
some AI layer, I don't know, to optimize the settings.
Yeah.
I feel it is very powerful, but then it also can sometimes there's a learning curve, I would say, to
Yeah. Yeah. Yeah.
understand the options and their impact correlations and so on.
Yeah. That makes sense. Let's talk a bit about the current limitations that
Mhm.
the platform has, and what's in future. What new features, or what limitations are going to be solved in future?
Right, that's good. I mean, in terms of limitations, that's a good one. I feel it's pretty feature complete. I don't think there is a lot of things where people think, hey, if I could do this particular thing with Debezium, this would be much better. I mean, I don't think that's the case. There is the one thing which comes to mind is the Oracle connector. So for Oracle, the thing is there is not like a really powerful CDC interface which comes with the database itself. There is one way which we currently use, which is called log miner. So that's a
Hmm.
view which you have within Oracle, which exposes the transaction log like as a view. So this
Yeah.
works, but there are some performance limitations to that. So this is something which could be better. Maybe there could be like a bespoke log file parser for Debezium. I think that's the one thing. And in terms of the roadmap, let me actually go to the project site itself. I need to read it up. What's on the roadmap? So I mean, yeah, Debezium UI, that's definitely a big thing. I mean, we haven't
Hmm.
spoken about that. And also,
Yeah.
there is a UI component for Debezium. This is
Okay.
constantly being built out. There is what's called the schema history compaction process. So that's another thing which we actually didn't touch on. So depending on the particular connector, if we receive a change event from the database, it may or may not be fully self-descriptive. So,
Hmm.
in the easiest case, we look at this event and it has the schema information, and we can make sense out of this event just by looking at it. So that's the simple case. That's for
Yeah.
Postgres, for instance, that's the case.
Yeah.
But then for other cases, it's not like that. You get the information and it has the change data in it, but you cannot really interpret it without knowing what are the column names or what are the column types. So that's a little bit like Google protocol buffers, right? If you look at a protocol buffer, you cannot make sense out of it without knowing the schema which you need to have upfront. So that's, for instance, the case for MySQL. And what happens for MySQL is we keep track of all the DDL operations, like all the create table, alter table, and so on. We keep track of that. We parse that. So there's a Antler-based DDL parser in a part of Debezium.
Yeah.
So we can have the schema for all the MySQL tables. And then if we receive a change event, then we will know, okay, this is how we need to interpret it. And now, of course, we need to also manifest and persist this schema history, because if we get restarted, we need to have that information again, because we won't get it again from MySQL. And in particular, what we cannot do is we cannot go to the database as it is now, because there might have been schema changes already happening, right? So there would be like a mismatch. So we need to persist the schema history. This is persisted in a Kafka topic, or one of the options is a Kafka topic. And now the problem is, there is, if you do many schema changes, this schema history topic, this can become quite large, and it will, if it has like 100K records which we need to read back upon connector restart, and we need to build up this in-memory model, this can take some while. So we want to have a compaction tool, which essentially, will just keep the current version of the schema as much as we need to safely read back the transaction log. So that's one. And maybe another one, which I'm really excited about, is we want to have a JDBC sync connector as part of Debezium. So, I mean, as we discussed, Debezium right now is just CDC. It's just the source side of such an end-to-end data pipeline, right? And now, of course, people don't take data into Kafka for its own sake. They want to propagate it elsewhere, into their data warehouse, other microservices, search indexes. They want to try streaming queries, whatever. So you need to have a sync site, or you need to reason about the sync site for that. So how do you take this data from Kafka into another database? And I would say having a JDBC sync connector, that would be a great thing, because that's the most common use case, I would say. Or let's say many resources on the sync side are JDBC addressable. And now I feel if there is a Debezium provided JDBC sync connector, this will be a very powerful thing, because then people can have those end-to-end data flows just by using the Debezium connectors. And also, we can take advantage of the Debezium schema, the metadata, all this kind of stuff. So I believe we can do a very good job, and probably a better job than existing solutions, in terms of how easy this is to configure, how can we apply schema changes, or how can we derive the right schema from metadata to begin with. So having such a JDBC sync as part of Debezium, I feel that would be a great thing, and I know the team is working on that.
Awesome. Yeah, very interesting. So looking forward to all the new features. Where does Decodable fits in this ecosystem? What kind of problem it is solving?
All right. Yeah. So and it touches a little bit on that last point. So yes, I have been working on Debezium and CTC for a while, and I think it's a very powerful tool. People love it. It's really popular in the open source community. There's lots of blog posts where people use it. But again, it is one part of a end-to-end data pipeline. There is a few other things which you need to have in place to make this really a reality. So there is the sync side. So we spoke about that. But then there is also this notion of processing your data. And I mean, you can do some things with those message transformations, Kafka Connect SMTs, but I would say only basic things. Oftentimes you want to do more advanced things. Like you want to do stateful stream processing, and this means so maybe you want to join data from multiple change event topics into a single one. Maybe you want to aggregate it, you want to group it, you want to, pre-materialize views before you put them into your database. All those kinds of stateful stream processing operations. And this is where Apache Flink shines. So I got interested in Flink and all this kind of stuff. And Decodable essentially is a managed stream processing platform based on Apache Flink. So it allows you to set up those data integration flows in a fully managed way. And then the way you go about transforming your data is about SQL. So part of Apache Flink is Flink SQL, and this is also what's leveraged by Decodable. So you define your message transformations, your joins, your aggregations, your windowed queries, all this kind of stuff in terms of SQL. And then, you configure this in the decodable UI or CLI, and then the service will take care of running this, spinning up the Flink jobs, scaling them as it's needed. So it's a fully managed stream processing platform with end-to-end connectivity based on Flink and Debezium and other things.
So basically taking this to the next level. So once you have the data in the streaming platform, what you can do with it, and how it can make it easy for you.
Exactly right.
Yeah, that makes sense.
And I don't want to make too much of a plug for it, but when I just use this for the first time, it was really powerful. So hey, I just configured a thing, this Debezium connector, I apply some transformations, put it there into some sync, and then all is taken care of for me. So all the running aspect, and I just felt, wow, that's really empowering to users that they can put all this responsibility to the service, and I feel it's really a cool thing.
Yeah. Like quickly get started with your streaming use case without going into much complexity of managing a Flink cluster and all that.
Exactly.
How can I try this? How is there like a try mode or something I can do?
Exactly. There's a free trial you can do. I mean, it gives you a specific amount of resources, like number of tasks and so on.
Yeah.
And you can play with that. No credit card required. Just go there, and you will have set up your first pipelines quite quickly, I would argue. And by the way, I would encourage you to do it to also because we want to have the feedback, of course. So, do people like it, or in particular, do they struggle with some things? Maybe something isn't as intuitive as it should be. That's definitely the feedback we're after.
Awesome. Yeah, I'm looking forward to try it out because I'm deeply involved into stream processing, mainly on the Kafka side. I'm very new to Flink. I've done one episode on Flink streaming as well, but I don't know a lot about it, so I might be trying out.
Absolutely, yeah, totally. I mean,
in a few weeks.
I'm also a learner in that space, right? I mean, I'm reasonably familiar with Kafka streams because I've used it for lots of examples and demos and so on. And now, as I'm learning about Flink, I mean, yes, the concepts, they are like related, right? I mean, it's kind of the same solution space, but then things have different names and details differ. There's things like
APIs
checkpointing in Flink, and oh man, it's there's so much to learn about.
It's a different world, yeah. Awesome. Well, I have learned a lot today about Debezium, about change data capture. It was really great talking to you about your experience with it, how you got involved into this project, and some of the patterns that you shared, what features are currently available, what's coming up in future. So I thank you again for joining us today and sharing all the amazing insights into the world of change data capture and the future that is coming up for it. So
absolutely.
Thank you so much.
Yeah, and thank you. I mean, it has been my pleasure. Thank you so much, KV, for having it. This was really cool. I enjoyed it a lot. And I guess you will share Twitter details and contact information. So if people want to stay in touch, you can reach out to me if you have more questions. I would be very happy to help you out.
Absolutely. For the viewers, if you like our discussion, please don't forget to subscribe to the channel and give it a like. We want to hear your feedback. And of course, you can try out Debezium, you can try out Decodable. You can always reach out to Gunnar if you need more information, and always reach out to me if you need something else. So thanks a lot for listening, and thanks, Gunnar.
Absolutely. See you. Bye-bye.
Bye.